Hi, my name is Z Haddad, and I'm the Department Chair for the Engineering, Transfer, and Physical Sciences at STCC. Well, my goal for this video is to show you how physics is used in sports. The truth is, physics is really used every single day in every aspect of our life. If you are walking down the street, you are using physics. If you're on the track and field team, you are using physics. If you're playing basketball, you are using physics. If you're driving a car, you're using physics. I'm going to focus in this video on physics and sports, especially basketball, since I'm a huge basketball fan. We're going to talk about free throw shot, three-point shots, look at different players and how they shoot, from Stephen Curry to Russell Westbrook to Isaiah Thomas. We'll look at every one of them and see what's the difference in their jump shot. So let's begin by showing what a free throw, actually a graph for a free throw, and what happens there. So this figure here represents me taking a free throw, and notice the ball goes in, hopefully. So now, to have the ball travel from this point up in the air, go higher and come down, then go to that point, you really have to push the ball in both directions. You have to give it a push in this direction, and you have to give it a push in that direction to go up in the air. And let's use some numbers just to make the math easy. Let's say we need 10 Newton to go in this direction, to make it go from here all the way to here. And let's also use 10 Newton in the y direction. They don't have to be the same number. That's n here. If I use different numbers, I'll forget which one's which. So that's why I'm using 10 for both of them. So the question becomes, where are these forces coming from? Where's the pushing come from? Who does the pushing on that ball? Well, the pushing comes from you at your shoulder pushing the ball. You're pushing it in the x direction, and you're pushing it in the y direction. So your shoulders and your arms are doing all the pushing there. Now, if you try to actually shoot the ball from down here, let's say somewhere behind the three-point line, without jumping, come on, what you're going to see is the ball going to travel like this, and it's going to be short because you're not strong enough to push it all the way there. There's only a few people probably have that strength to throw the ball without jumping from half court or the three-point line. So how does Stephen Curry, who is as skinny as they come, shoots the ball from anywhere on that court and makes it? Well, let's take a look at Stephen Curry.
Is similar to how Steph Curry shoots.
Notice the minute he jumps up in the air, he releases the ball. So let's stop here, analyze his shot. So let's take a look at what Stephen does. First thing I noticed, he wasn't flat-footed. He jumps up in the air. So let me draw a picture of him jumping in the air there. Oh. So there's Stephen. So right before he takes that shot, he jumps straight up in the air. Let's give it a speed. Let's say 1 meters per second. About 3 miles per hour. Well, what is that going to do? That's going to give the ball an initial force, initial velocity in this direction, which means the force in the y direction doesn't have to be 10 now. He might only need 5 Newton in this direction to make the ball travel the same height in the same distance with that jump. So every time he gets that ball, he jumps straight up in the air, and the minute he starts to move up there, he releases the ball. Let's take another look at it. Watch him. Jump, release. Jump, release. Let's compare Stephen Curry to somebody like Derrick Rose. Well, if you ever seen Derrick Rose, his muscles like Popeye. Well, his jump is really not a nice jump, because what Derrick does, he jumps up in the air, he keeps rising until they hit the apex. Once he hits the apex and start to come down, that's when he releases the ball. So actually what Derrick does, releases the ball on the way down. So while he's coming down, he releases the ball. Let's say 1 meters per second. We'll use the same number. So that gives actually the ball a velocity in this direction, a force in this direction, which means he has to push with a force larger than 10 Newton in the y direction. So his force now in the y direction will be much larger than 10 Newton. It might be 20 Newton or 15 Newton. Why? Because he's coming down, moving down. That's going to give him a momentum in this direction. Compare that to what Stephen did. Stephen only had to push a force in this direction of 5 Newton, where Derrick Rose has to be 4 times that number. Let's take a look and see what happens with his jump shot. Let's take a look at it. Here's Derrick Rose taking a jump shot. Watch, he gets up there, on the way down he releases the ball. Up in the air, on the way down. Up in the air, on the way down. Every single time. So every time he takes a shot, he waits till he starts to slide down, then he releases the ball. Now let's look at Russell Westbrook and see what he does. Well, the way Russell actually shoots, he jumps up in the air. When he hit the apex, when he's not moving, he releases the ball. So at the time he releases the ball, he had no velocity, 0 meters per second or miles per hour. He's not moving in the y direction. That means he still needs 10 Newton in the y direction. So just like if he shot it flat-footed, so that jump really doesn't do anything in terms of strength for him. It doesn't help him. What it does actually for him, if there's somebody in front of him that's a taller person, they don't block his shot. So by jumping up in the air, you can avoid the block, but it really doesn't add or change the value of that force or the value of this force. And so let's take a look at his jump shot. Wait, look at him, up in the air, apex, shoots the ball. There we go. And now he shoots it. Let me stop him. Now let's look at Isaiah Thomas. Isaiah actually jumps forward in this direction. Let's say it's 1 meters per second. Speed there. And what that does, he said, he doesn't have to push with the large force in this direction now. That force in this direction can be smaller. Oh. So the force in this direction now can be smaller than 10 Newton. It might be 5 Newton. But in this direction, he still needs the 10 Newton. And if you watch Isaiah Thomas, every time he takes a shot, he lands inside where he started the jump. He might start outside the 3-point when he takes the shot, but when he lands, he's inside the 3-point line. So let's take a look and see what happens with him. Here's Isaiah Thomas taking shots. Watch where he takes it. Look where he lands. Inside. Every single time. Watch. He lands inside. Outside, inside. Outside, inside. He moves forward. And now let's look at one more player. We'll look at Kyle Korver. Now Kyle actually does two things. He moves in both directions when he shoots. He moves in and he jumps up at the same time. So let's say this is 1 meters per second up there and 1 meters per second to the right. That means in the x direction, he only has to apply a force of 5 Newton. And in the y direction, you only have to apply a force of 5 Newton. So it really doesn't take a lot of muscle by him to get the ball to travel that distance. Minimal strength he needs. And let's take a look. And this actually I know from one of the games there, but watch where he lands when he shoots up in the air. He goes forward and he also jumps up at the same time. And that'll leave us with one more question. One more question. Why do they spin the ball? Well, the reason you want to spin the ball is to make sure you soften the ball when it hits the backboard or when it hits the ground. Just to show you that, let me just show you this video here. Notice the ball is coming in, it's going to hit the ground, and it's going to bounce in the same angle if you don't spin the ball. But if you put a back spin on it, come on, notice where it lands. So when you hit the back board there, you don't want the ball to bounce outside the rim there. You want to soften the ball, and that's why I always tell you, when you finish with that jump shot, your finger should be pointing straight down toward the ground. So hopefully that's going to help some of you play basketball.